Okay, Math 3, we're looking at multiplying and dividing with rationals. So basically we just do a quick review of what it means to multiply any kind of fraction. It's a numerator times a numerator and denominator times denominator. And what you see very clearly, and this is all from old school, is just straight across on the bottom. You end up with 10 over 12, which reduces with a common factor of 2 to 5/6. Okay, you take that same exact concept and you move it down here. Now, what I'm going to show for you right here, I'm going to show you the long way to do it that doesn't help you. So let's just kind of bear with me for a second. I do the numerator times the numerator and denominator times the denominator. Okay, and that's just going straight across, just like we talked about. And then I go ahead and distribute those. Now, if I do that, now I'm in a situation like yesterday. Okay, and how did we solve yesterday? How did we simplify yesterday? Well, to simplify yesterday's, we took and we factored both the numerator and the denominator. Well, wait a second. If I factor the numerator and the denominator, didn't I just undo everything I just did? All right. So what we just found out was that we kind of wasted our time a little bit. Okay? And by wasting our time, what I mean is, first we multiplied, and then we factored. And when you factor, you undo multiplication. So why multiply to begin with? Instead, let's just write everything out in factored form. We're going to write everything out in factored form and try to cross-cancel common factors like we did yesterday. To go back to our original example, once upon a time, some of you remembered that you could cross-cancel these right here. And to back that up, we know that 2 in the numerator, 2 and 4 both have a common factor. So I can cross those out. And then when I multiply, I can get straight to the answer without any reducing. We're going to go for the same concept here. I rewrite my x squared as 2x's. And I factor the bottom into two binomials. Well, now look, this is being multiplied by that. Everything is multiplication on top. As a matter of fact, I might even add that to it. These are being multiplied straight across, and these are all being multiplied on the bottom, so I'm allowed to cancel away anything that will. Okay, you recognize that these two are common factors on the numerator and denominator. Those two are common factors on the numerator and denominator. And what I'm left with is x over x plus 2. Now, of course, there's a restriction on the denominator, but we'll talk about that. We've already done that another day. Take your time, look over that again if you need to. We're going to do division. Division follows this rule right here. Remember, once upon a time, we learned to divide fractions. We actually never divided fractions. Almost everybody changed it to a multiply problem, and we multiplied by the reciprocal. So it would have looked like this. Instead of division, we multiply. And instead of 5/6, we do the reciprocal 6/5. Now the first one stays the same, and that's why I have same, switch, flip. Some people remember that. Same, switch the sign, flip the fraction. All right, and now guess what? Now it's a multiplication problem. So I can multiply straight across like I did, or some people recognize the 4 and the 6 can cross-cancel. So if I cross-cancel the 4 and the 6, make it a 2 and a 3, again, I get the same answer. And again, that's the emphasis, is that we're going to try to find common factors and get rid of them. So let's look at this example here and do the same idea. Instead of division, we're going to change that to multiplication. Well, first off, this one stays the same. Instead of division, we're going to change it to multiplication. And instead of this fraction, we're going to flip it. And now, without wasting our time like we did on that other one, we're just going to go ahead and try to factor everything out and see what we can do. X squared is really 2x's. All right. X squared minus 1 is the difference of two squares, so I factor it like this. X to the fifth is really 5x's. And now I start trying to find things that will cancel each other out. These two cancel each other out. 2x's on top will get rid of 2x's on the bottom. And I'm left with x minus 1 over x to the third. Okay? Now, yesterday we had, go ahead and look through that as often as you need to for multiplying and dividing. Yesterday we had a situation come up where sometimes we have to take out a -1. So here's a real quick example of what that might look like. If I factor the numerator, I look at this situation here, and some people are tempted to cross that out, but they're not the same. Okay, these are not the same, but they end up being really, really close to the same. They're actually exactly opposites of each other. So what I'm going to do instead is I'm going to take one of these two, and I choose the bottom one, and I'm going to factor out a -1. So I'm going to take the bottom one and factor out a -1. So there's the numerator. And on the bottom, I factor out a -1. It looks like this. Now the question is, are these two the same? And the answer is yes, these are the same. Because I can rewrite that as x minus 5. And now you can see that they are the same. And that's what we're looking at. Guys, take your time with your homework tonight, and look forward to answering questions tomorrow.